Hello students. So now we know what happens when an acid or a base is dissolved in water. When an acid is dissolved in water, the H plus ions are given out and they exist with water molecule in the form of H3O plus or hydronium ion, which is responsible for the acidic nature of the solution. In a similar way, when a base is dissolved in water, the hydroxide ions are given out and they exist with water molecule, and we are supposed to write them as OH minus aqueous. Let us now try to understand how do we write such equations when acid or a base is dissolved in water. So for example, if you have to write down what happens when HCl is dissolved in water, so HCl when dissolved in water is going to give you H plus aqueous, and along with this you are also going to get Cl minus aqueous in water. In a similar way, let us now take another reaction. What if I dissolve H3PO4 in water? Now here you can see that 1 mole of H3PO4 has 3 moles of H plus ion. So when I dissolve it in water, it is going to give me 3 moles of H plus. So I am supposed to write this as 3 H plus aqueous. And along with this, the negative ion, that is phosphate, so I'm supposed to write it as PO4 minus 3 aqueous. Let us look at another reaction. Now for a base, what if I dissolve MgOH whole twice in water? In this you can see that MgOH whole twice has 2 moles of OH. Therefore when it will be dissolved in water, it will give us 2 moles of OH minus. So I'm going to write this as Mg plus 2 aqueous, and along with this it is going to give me 2 OH minus aqueous. Now you may try to complete this equation on your own. We are thus clear with the fact that acids when dissolved in water give H plus aqueous and bases when dissolved in water give OH minus aqueous, which is responsible for their acidic and basic behavior respectively. Let us now talk about how do we determine the strength of an acid or a base. The strength of any acid or a base is actually determined by the amount of ionization that occurs. Let us try to understand this with a little more clarity. For example, if I am taking an acid like HCl, then the acid like HCl is a strong acid. Why do I call it a strong acid? The reason is because when I dissolve it in water, it completely dissociates into water, it completely breaks down, it completely ionizes and gives me H plus aqueous and Cl minus aqueous. I mean to say that suppose if I have dissolved 1 mole in water, 1 mole of HCl will completely dissociate and will thus give me 1 mole of H plus aqueous and 1 mole of Cl minus aqueous. Since the entire 1 mole has dissociated, I will say that this is an acid that dissociates completely or splits up completely or ionizes completely into its ions. But instead of HCl, suppose if I would have taken an acid like CH3COOH, that is acetic acid. Now when I take 1 mole of acetic acid and I dissolve it in water, what do we find? That the entire 1 mole does not dissociates into ions. Instead, or rather let us say, only 0.005 mole of it dissociates. Therefore, obviously when I'll dissolve 1 mole of acetic acid, it will give me less number of H plus aqueous ions in its solution. The reason is because it has not completely dissociated. So such acids which partially dissociate, which do not completely break up into ions, but only a part of them, only a certain amount of them dissociates or splits into ions, thus giving us less number of H plus ions, are called weak acids. So now we know how do we define strong or weak acids. To get a clear idea of it, look at the picture here for a strong acid. What do you find here? All the H plus has completely dissociated. But now look at this picture of a weak acid. And what do you find here? That only some of H plus has dissociated, some of it is still undissociated. So this is an acid which partially dissociates and therefore is called a weak acid. And this one is an acid that completely dissociates and therefore is called a strong acid. The same can be applied for bases as well. Those bases which would completely dissociate would be called strong bases, and those which would partially dissociate would be called weak bases. I hope now we are very clear with how are we going to define strong and weak acid and base. So the definition for a strong acid is supposed to be written in this way. Acids that dissociate completely to produce large number of hydrogen ions are called strong acids, and you will all remember three examples of strong acids. These are HCl, HNO3 and H2SO4. In a similar way, acids that partially dissociate and produce less number of hydrogen ions are called weak acids. And you will also remember the examples of weak acids. These are acetic acid and carbonic acid, that is H2CO3. In a similar way, the example of strong bases are only two, NaOH and KOH. And the examples of weak bases are going to be magnesium hydroxide, calcium hydroxide, and ammonium hydroxide. You will all have to remember these examples of strong and weak acids and bases. Let us go to one very interesting thing, dilution of acid or a base. When I say I'm diluting acid or base, I mean to decrease the concentration of H plus or OH minus per unit volume. To understand this, look at the picture. In this picture, I have got H plus ions only in 1 liter, but if I increase the volume to 2 liters, per liter, the amount or the concentration of ions would decrease. Look, as soon as it volume increases to 2 liters, per unit volume, the concentration of H plus ions you can see goes on decreasing. Thus, when we decrease the concentration of H plus or OH minus ions per unit volume means 1 liter or 1 milliliter. Here we'll talk about 1 liter. So when we decrease the concentration of H plus or OH minus ions per unit volume, the acid or base is then said to be diluted. How do you dilute an acid or a base? So you will always remember that while diluting, we always add acid or base to water and never add water to acid or base. You can look in the picture, a very strong acid, sulfuric acid, is added drop by drop to water with constant stirring, as you can see in picture number 2. Because this process of diluting acid or base is highly exothermic, a lot of heat is given out. It is always therefore recommended to add acid or base to water drop by constant stirring. Because if you add water to an acid or a base, the heat generated would be so large that acid or base may splash out and the glass container may break. It is therefore always important while diluting acid or a base to remember that acid or base must be added to water drop by drop and with constant stirring so that we can prevent accidents. Thank you so much. We will again meet with a new lecture very soon.